Okay, so now we're going to look at part C, and this is all to do with crossing the y-axis. So part C, we're crossing the y-axis, and look, there's 4 points where they cross. Now, as this parameter t goes from 0 upwards, we're getting this closed loop. And as t goes on, we're going to have multiple crossings, multiple crossings, multiple crossings. From the diagram, we can see that basically we only need to find 4 values on there for our solutions, and then we would see repetition. So we only need to find 4 values of t, and then we can work out the coordinates from that. So we're only looking for 4 crossings. All right, so we only need 4 crossings. Now, they all cross the y-axis, so these are all when x equals 0. So let's solve that out. We've got our x equation there from our parametric. So we know that x equals 8 cos of 20t. So we're going to solve 8 cos 20t equals 0. So that's going to be cos 20t equals 0 if we divide through by 8. And then we've got to think about values of cos in here that will give us 0. Well, it's going to be pi by 2, 3 pi by 2, 4 pi by 2, etc. So we can say that 20t is equal to, and we just need the first few. So pi by 2, we're going to have 3 pi by 2, we're going to have 5 pi by 2, and then we're going to get 7 pi by 2. All right. Now we can actually work out what t is, but I've read ahead a bit here, and we're going to be substituting back into here. So actually, I might find out what 20t minus pi over 3 works out to be. So, 10t minus pi over 3. So we can work out what 10t is by just taking half of all of these. So we just divide everything through there. So we've got that. And we can actually save ourselves a little bit of time and effort here by working out what 10t minus pi over 3 is. Alternatively, you can just start bunging these values in through the calculator. But I like to see all these 4 different things here. So when we've done that, if we take away pi over 3 from here, we need a common denominator of 12. So we know they're all going to be over 12. 12, 12, 12. And there's going to be 4 of them. And then think about it. That's going to be times by 3. And we'll be basically taking away 4 pi each time. So that's going to be okay, so first one is going to be 3 pi take away 4 pi, which is just negative pi over 12. Next one, we're going to get, what we're going to get there? So we're going to get 5 pi over 12. We're going to get 11 pi over 12, and we're going to get 17 pi over 12 as our values. Okay, so there are four crossing points. We want to find the y values for these that go along with it. So I suppose we could try and squeeze it on here. Oh no, let's go up here. So let's find the y values. So we would just have to do 12. I'm going to use all these here. 12 sine of that value. So we're going to have when x equals negative pi over 12, we're going to get y equal to 12 sine of, so it's negative pi over 12, and that comes out on your calculator as minus 3.11. All right, when x is the next one along, 5 pi over 12, we get y to be equal to 12 sine of that, and that comes out as 11.59. And we keep going. put that through your calculator, you get 3.11. Oh, that's looking good because that's the positive version of the other one. It's looking familiar. So 17 pi over 12 y equals 12 sine of 17 pi over 12. And this one, prediction time, we're hoping it's that one. And when you do put it through your calculator, that is what you get. So you get these crossing points here. So you get and the y at minus 3.11. Did we have to find all the coordinates or just the y values? So we need the coordinates. So we need to put it all together now. Quite a long question. This is the bit where you're all fast forwarding in it. Now we should write a little bit quicker. And then minus 11.59. All right, still on the page. Good. So there are our answers basically for C. Now, part D takes a little bit of thinking about. We have to work out how long it takes for the figure skater to complete one figure of 8 motion. So we realise that cos takes 360 degrees or 2 pi to complete a full period. Sine takes the same, 2 pi to complete a full period. Now, because with cos here, it's 20 times quicker to go through the period. As t goes between 0 and 2 pi, it will go round that cycle 20 times. So if we just think about cos, or the x basically, this doesn't matter because it's just a stretch. We're really bothered about the 20t part. So for cos, we need to make this bit 20t go through a period of 2 pi. So it's gone around its whole cycle basically. So what we'd say is the period, as in going through a full cycle, is 2 pi over 20. It's going around that cycle 20 times for every 2 pi. All right. So it's going to be multiples of that for that period. All right. So the next one up would be 4 pi over 20. Then you're going to get 6 pi over 20. Then you're going to get 8 pi over 20, etc., etc. For sine, the y and sine, you've got a similar deal, but we've got 10t for it to complete its cycle of 2 pi. So the period here is 2 pi over 10. Now these fractions simplify down, but because we're just kind of working in, we're working in 20s up there, so let's just work in 20s down here. Or you could, well, it's probably more mathematical if we change these. So let's say it's pi by 10. This one's going to be, underneath it is going to be pi by 5. That's going to be 3 pi over 10. Oh, different denominators, so maybe not as great here. You know what? I'm sticking with that. Keep that mistake in there. So let's just turn this into 4 pi over 20, and we're going to use denominators of that. So, oh, hang on. We've actually got a match there. So what we're looking for is the lowest common multiple of these periods and this period here, and we found it. So that period is just simply 4 pi over 20. It's the lowest common multiple of the two periods there for sine and for cos, for x and for y. So we want to know that time. So this is t has to equal 4 pi over 20, which I suppose is just pi over 5. Now, when you put that through a calculator, that gives you, pi divided by 5 gives you 0.62831 minutes. All right, and just to finish it off, that is equal to 37.7 seconds when you round it off, times it all by 60 to 1 decimal place. All right, so huge amount of work there, lots and lots to think about. And as always, practice, practice, practice.